Dimensional analysis is a tool that we use in chemistry to do units conversions in a convenient and reproducible way. It's a method for setting up problems that enables you to tell when units are properly canceled and converted to a new unit. And we're going to talk about that today. You can read about it in section 7 of chapter 1. So let's start by setting up the whole idea of the problem. The idea is, put in somewhat silly terms, that you can always write a violin in terms of a piano as long as you multiply it by a violin divided by a piano. Here the idea is that the piano in the numerator here cancels out with the piano in the denominator in this ratio, and so you end up with just violin equals violin. Of course, I could have set this up in less whimsical terms, I suppose, by saying y is equal to x times y divided by x. All we're doing here is algebra, where we're canceling out the x and getting y equals y. And that's what we're going to be doing with units in this method of dimensional analysis. So if we look at some sample conversion units, 2.54 centimeters is exactly equal to 1 inch. You don't need to have known that. I'm telling you that, and it's an exact conversion. This is our modern definition of an inch. 1 liter is 1,000 milliliters, or 1,000th of a cubic meter. And we know that 1 milliliter is a cubic centimeter. Those things are equivalent. So when we say 2.54 centimeters is equal to 1 inch, we of course don't mean that 1 is equal to 2.54, but rather if we measure length in centimeters, and we measure 2.54 centimeters, we end up with the same length, that same quantity, as if we measured 1 inch. Now we produce conversion factors from these conversions by simply dividing one of the values by the other. So for example, 2.54 centimeters divided by 1 inch, those are literally the same length. Again, I'm not saying that 2.54 is equal to 1, I'm saying 2.54 centimeters is the same length as 1 inch. And it's equivalent to saying that 1 inch is the same as 2.54 centimeters. I can write it in either order. And in fact, I can even write it in a somewhat less familiar way by saying it's equal to 3.937 inches per 1 centimeter. Where this number here I get by literally taking 1 and dividing it by 2.54 on my calculator, and I get 0.3937. Once again, I'm not saying that 0.3937 is equal to 2.54. I'm saying that when we measure it in these units, we get the same distance. And this is the key. Once I set it up in this conversion factor form, I can treat the units just like I treated the piano and the violin up here and set them up so that they can cancel algebraically. Let's see how to do that in an example. So as a simple sample problem, how many centimeters are in 20 inches? Now maybe you can set this up without thinking about it very much, but I want to go through this formal way of setting it up using dimensional analysis. So the steps you should take: identify the unit that is in the given number. We're told 20 inches, so the unit is inches. But we want to get it into centimeters, so that's our desired unit. So now we're going to set up a conversion factor. We write down the given value, 20 inches. We set up the conversion factor in such a way that the inches in the numerator here are algebraically canceled by the inches in the denominator in our conversion factor. So I can cross these out, not just because there are 2 inches in the problem, but rather because algebraically an inch in the numerator divided by an inch in the denominator cancels out. And so we end up with our answer, which I hadn't actually calculated. So we get, let's do that in a different color, 50.80 centimeters. And we get centimeters because that's the unit that's left uncancelled. Notice that if I start with 4 significant figures here, and I multiply by a conversion factor that is exact with no uncertainty, then I can retain all four significant figures in my answer. Now let's apply this to metric conversions. My recommendation, you don't have to do it this way, but my recommendation is to always do a metric to metric conversion by taking the given value and converting it into an unprefixed unit. I say unprefixed, not base unit, because of course in this case kilogram is the base unit, but we really want to convert to the gram because the metric prefixes are all based on that word. That's the reason we do it this way. So we're going to convert to an unprefixed unit, then convert from the unprefixed unit to our target unit, micrograms. So let's set up the conversion factors for this conversion. So I want to go from kilograms to grams. So my conversion factor, I know, is going to have kilograms in the denominator so that it can cancel out my kilograms here. I want to go to grams, and now I just figure out where to put the numbers. So 1 kilogram is 1,000 grams, and that would allow me to cancel the kilograms. And now I multiply by another conversion factor to go from grams to my target unit, which is micrograms. So again, I use the units that I have to guide what I do. Grams is in the numerator here, so I want grams in the denominator so that it will cancel. I want to end up with micrograms. Let's see, micro is 10 to the minus 6th. So 1 microgram is 10 to the minus 6th grams. And now I multiply this out. So I have 27.3 times 1,000 and divided by a million, or same thing as divided by a millionth, sorry. And we get 2.730 times 10 to the 10th micrograms. Again, keep in mind this is a significant figure over here, so we want to keep that as our significant figure in proper scientific notation. Now, sometimes you have several conversions that you have to make, and I recommend when you do chains of conversions, so let's work through an example and see how to set it up first. How many centimeters are in exactly 1 mile? Well, I know 1 mile is 5,280 feet. I set it up so that the miles cancel. Let's do the cancellation here. That leaves me with feet. Now I want to get rid of the feet, so I divide by feet using 12 inches per foot. So that cancels the foot. And now I have inches. I want to get rid of that, so I cancel the inches with 2.54 centimeters per inch. And I get 160,934.4 centimeters. And that is a correct answer because all of these are exact conversions. Now what I recommend when you have multiple conversions like this in a row, enter them all into your calculator at one time. Don't write down intermediate results. Don't use parentheses if you can avoid it. So literally what I type into my calculator when I calculate this is 5280 times 12 times 2.54 equals. That's what I get. Don't have to write down intermediate results. It's quicker. It's less subject to round-off error. So try to do that when you set these up. Let's do a slightly more complicated conversion. Make sure you're following the proper algebra so that the units get canceled. So, and it's not, here's the power of dimensional analysis. You don't have to know what the units mean in order to use them. So here I'm setting up an example using just nonsense units. Doesn't matter what the units mean. It's just algebra. Think of them as x's and y's if you like. Set it up so things cancel. So let's set up this problem. Let's see, how many microzirks are in 2.5 kilozirks? Here's our conversions given. 5 zirgs per 1 ACK, which is exact. 17.2 ziks per 1 ACK, apparently not exact. So again, we're going to start with what we're given, 2.5 kilozirgs. I'm just going to set it up. First thing I'm going to do is convert my metric prefix to the unprefixed unit. So I want to get rid of kilozirgs, replace it with zirg, and by definition of kilo, 1 kilo is 1,000 of whatever this unit is. So now I've converted to zirgs. And now I know I want to get rid of zirgs. So I set up a conversion factor and I put zirg in the denominator so that it will cancel with my zirg in the numerator. So then I look at my conversions. See, the only conversion I have is 5 zirgs is 1 ACK. So I guess I'm going to convert to ACKs. And the 1 goes with the ACK. Any 5 goes with the zirg. And now just do my units conversions here. Zirgs cancel out. I'm currently in units of ACKs. That's not what I want. I want microzirks. So I'm now going to set up conversion that cancels out the ACK here. So I want ACK in the denominator. And my conversion is 7.2 ziks per ACK. I'm going to put ziks in the numerator. 17.2 goes with the zik. And 1 ACK. And now I've gotten rid of the ACK unit. And now all I have to do is convert to the microzirks. And to do that, let's see, I want to get rid of my unit of zik. So put zik in the denominator. I want microzik, my target in the numerator, and there's 1,000,000 microziks for 1 zik. Once again, my units cancel, and I multiply all this out, and I get the answer 8.6 times 10 to the 9th microziks. Just double check my significant figures. I started with 2, I end up with 2. Looks good. All right, one last example. We have to make sure that the units match when we cancel. Okay, so in my example here, the displacement of a car engine is 289 cubic inches. What's the volume in liters? As at a first blush, you might want to write down 289 cubic inches and then use our centimeter to inch conversion. But if you look at this, you'll notice inches cubed here. That's inches times inches times inches. That will only cancel out 1 inch in the denominator. I need inches times inches times inches. And the way we do this is we take this entire conversion factor and raise it to the 3rd power. So now I have centimeters times centimeters times centimeters in the numerator, inches times inches times inches in the denominator. And when I multiply this out, I get 4.73586 liters. Now, that's not how the answer should be reported because, of course, I started with 289 cubic inches. That's 3 significant figures. So I want to round this number to 3 significant figures. I've got a 58 here that's closer to 100 than 0, so I'm going to round up. So my final answer here is 4.74 liters, rounded to the proper number of significant figures.